Hello my lovely viewers. Today we want to look at a very special topic, and that special topic is isomerism. Isomerism. Now when we look at isomerism is a phenomenon or occurrence of a compound having the same molecular formula but different structural arrangement. A compound having the same molecular formula but different structural arrangement is what we call isomerism. Now this isomerism is divided into two major types. Isomerism is divided into two major types. We have what we call structural isomerism, and we have stereo isomerism. We have structural isomerism and we have stereo isomerism. Now under structural isomerism, we have different types of structural isomerism. Under structural isomerism, which is, we say one, structural isomerism, we have one, we have chain isomerism. Let's say A, chain isomerism. B, we have what we call position isomerism. Position isomerism. C, we have what we call functional isomerism. Functional isomerism. We have what we call metameric. We have chain isomerism, position isomerism, functional isomerism, metameric isomerism. Now, under stereo isomerism, which is two, under stereo isomerism, we have one, we have geometric isomerism. We have geometric isomerism. We have optical isomerism. Now when we look at chain isomerism is a type of isomerism where a compound have the same molecular formula but different structural arrangement. This one is carbon-carbon, all right, nothing different. Now it's mostly found in a member of alkane, such as, for instance, now all alkane. Now in this chain isomerism, butane is C4H10. Now, how many ways can you write the structure of this compound? That is what we call isomer. The way this compound is, you can write it in different way. The way you write it in different way is what we call isomerism. Now you'll be asked, how many isomers are here in this compound? How many ways can you write this compound? All right. Now I'm going to give you the formula you can use to write the isomer of what? Of alkane. Formula of writing isomer of what? Of alkane. Now if you are watching from all my social media platforms like Facebook, Instagram and TikTok, a complete video of this isomerism will be uploaded on my YouTube channel. Just go there, look at my YouTube channel name here, Ojemai TV. Just go there, type isomerism by Ojemai. The complete video of all these isomer or all these types of isomerism will be discussed extensively on that video. But for this other platform, I'm going to shorten it. All right, after giving you the formula, I'm going to shorten it. All right, then the complete video will be uploaded on my YouTube channel. As you watch, do well to subscribe, and importantly, turn on your notification bell so that anytime I post video, you will be the first person to see it. Now let's go. Now this alkane, we have isomer start from C4 to C7. Anytime you are given a formula of C4 to C7, there is a particular formula that you use, and that formula is 2n minus 4 plus 1. From carbon number 4 to 7, this is the formula. 2 raised to power n minus 4 plus what? Plus 1. Use this formula to get the total number of what? Of isomer. For instance, I want to get isomer of this butane. How many isomer are here? Now, C here is your n. So I will simply say 2 raised to power what? 4 minus what? Minus 4 plus what? 1. So 4 minus 4 will give us what? Give us 0. So 2 raised to power what? 0 plus what? Plus 1. Anything raised to power 0 is what? Is 1. So here will be what? 1 plus 1 equals to what? 2. So there are two ways you can write the formula of this compound. Are you following? So you use this formula anytime you see a carbon chain having carbon from carbon number 4 to carbon number 7, you use this formula. Then from carbon number 8, C8, if you have a chain, an alkane chain with carbon number 8, use this formula. 2n minus 4 plus 2. Are you following? 2 raised to power n minus 4 plus 2. This is for what? This is for octane. The number of isomer that can be found in octane, you use this formula. Now, for carbon number 9, what you are going to use is what? For carbon number 9, you use 2 raised to power n minus 4 plus 3. Plus 3. This is the formula you are going to use if for nonane. Like if a carbon number, like a formula having what? C9. If it is C9, use this formula. Are you following? Now for carbon number 10, when it is C10, what the formula you are going to use is 2 raised to power n minus 4 plus 1 plus n. Now let's go to position isomerism. In the case of position isomerism is a type of isomerism where a compound have the same molecular formula but different position of the functional group. The same molecular formula but different position of the functional group. For instance, now I have butene written as what? C. Now, this is what? Butene. You get that? Now, this butene can be written as C. You can see that this one is now what? But1. So this is what we call position isomerism, where a compound have the same molecular formula but different. The position of the functional group is what? Is different. So we have a case of this one is but2 and what? But1. Do you get that? Now, in also you can see it in the propanol. See here, let's just say like this, OH. Have you seen? This is what? Propan1-on. Propan1-on. Now this propan1-on can be written as 1, 2, 3. This is time 1. This is what? Propan2-on. You can see that the number of the number of hydrogen atom and carbon atom are the same, but the position of the functional group is what? Is different. That is what we call what? Position isomerism. Position isomerism. Now let's look at group. A compound have the same molecular formula but what? Different functional group. For instance, now we have a compound like this: C3H6O. Now this compound can be written as, we have 1, 2, 3. Carbon atom are 3. We can have 1 here. We have H 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 here. We have what? H here. Alright. Now this same compound can also be written as, we have 1, 2, 3. We have now count the number of hydrogen atom. Here 1, 2, 3, 4, 5, 6, 6. One oxygen atom. Now in this case now, are you seeing? We have different functional groups. The functional group of this one is alkanal. So this one is called propanal. Propanal. Why this one is called propan 1? So this one is of ketone. Why this one is of what? Aldehyde. So a compound having the same molecular formula but different functional group is what we call functional isomerism. Functional isomerism. Do you understand? Do you understand? Now let's go to metameric isomerism. Now when we look at metameric isomerism, it's a type of isomerism where a compound have the same molecular formula but they are the different alkyl group attached to the functional group. Are you following? Different alkyl group attached to the what? Functional group. For instance, now we have something like C4H10O. Different alkyl group, mostly common in ethers. Ethers. Now this one can be written as, we have CH and we have another one. This is what we call metameric isomerism. You can see that the alkyl group, look at here, we have this is what we call methoxypropane. 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 Methane. Look at methane and propane. Methoxypropane. This is a functional group of ethers. Are you following? In the case of this one, this is an ethoxyl ethane. Ethoxyl ethane. Ethoxyl ethane. Look at ethane here, ethane here. This one is methane here, propane here. So all of them have the same molecular formula, but different what? Different alkyl group. That type of isomerism is what we call metameric isomerism. Metameric isomerism. Now let's go to, we are done with what? Structural isomerism. Let's go to stereo isomerism. So that in stereo isomerism are divided into two major one. We have other one, but the major one is, we have geometric isomerism and we have geometric and we have optical. Now, in the case of geometric isomerism, it's common in member of what we call cis and trans. Cis and trans in what? In butene. Butene. Now, the structure of butene is what? C. This is butene. This is a typical structure of what? Butene. Now, in the case of this geometric isomerism, we are looking at a structure having the same bonding type, the same bonding, but different spatial arrangement. Are you following? Different spatial arrangement. Like in the case of this butene now, butene can be, we have what we call cis and trans. Cis, we have something like this. This is what we call, in the case of this one, we have cis, both, two in. Cis, both, two in. Now, in the case of trans, we have something like this. So here we call what? Trans, both, two in. You can see the difference. There is a spatial position, the position of the methyl group. Look at here, they are arranged in the same direction. So since they are arranged in the same direction, we call it what? Cis. But here they are arranged in opposite direction. So since they are arranged in opposite direction, it's called what? It's called trans. Do you get that? So this type of isomerism is called what? Geometric isomerism. No common in what? In cis and trans. Are you following? Now let's look at optical isomerism. In optical isomerism, we have to look at the optical arrangement of different functional group attached to a carbon atom. Different functional group attached to what? A carbon atom. For instance, now we have lactic acid. It is lactic acid. That way there is a special rotation. All right. There is a mirror. This one we have a mirror. A typical example. Let me just illustrate. We have H6O3. A compound. This is lactic acid, and this lactic acid, we have a carbon atom attached to OH, attached to H, attached to CH3, and attached to okay, let's just say COOH and what? CH3. This is the, and you can see that when you see optical, the different they have different functional group attached to the central atom, which is the chiral atom. Now look at now this is carboxylic attached to this one. This is OH hydroxyl attached to this one. So different functional group attached to what? To this locant. So that is what we call optical. It has what? A plane mirror. All right. Now we have another one. This compound can also be written as you can see that there is a rotation, there is a change of what? Position of what? OH and what? And H. Look at this. OH here is down, OH here is up, H here is up, H here is what? Down. So this type of isomerism is what we call optical isomerism. For more of this, you will do what they always like. Remember, turn on your notification bell to see any video that I post. You'll be the first person to watch. Thank you very much for supporting. God bless you.